Hello guys, welcome to my
atomic theory lesson. So one day, this guy Democritus was sitting there, staring at a rock. Exciting, I know. He was thinking, what if I chop this rock in half? And chop it again, and again, and again. Eventually it has to be so small, it's uncuttable, right? I mean, that's what I said about the school lunch yesterday. Couple thousand years later, some Albert Einstein-looking dude sees some light in a tube.
It's an electron.
A while later, some Joseph Stalin-looking dude discovers that foil is bouncy. Then you have this other guy with his hair pushed back to meet Democritus himself, who discovered that electrons live in these little circles, spinning around these other circles, and... oh, what was that?
It was a spectra.
Yeah, so I guess the little guys can move over here. Hey, I have an idea. Let's shoot some of the little guys into these holes and see what happens.
Wait.
So basically, if you want to know where one of these little guys are, the answer is simple. It's here, and here, and here, and here, and here, and here.
It's a superposition. Oops, you looked and now it's gone.
Then this dude named Schrodinger invented an equation that tells us the probability of the little guy being in a specific spot when you look at him. Oh, what's that? You want me to read it? Sure. But he didn't like it, so he proposed a solution, as all things are. Animal abuse. Take a cat, a little guy detector, and some poison. Put the little guy here, knowing that he may eventually move to here, triggering the little guy detector, releasing poison and killing the cat. Now lock the cat in Braden's basement and wait for a little bit of time. Now the little guy is in a superposition, meaning he's here and here at the same time, meaning the trap is triggered and dormant at the same time, meaning the cat is dead and alive at the same time. How can this be? I don't know, you tell me, I'm out.
Hey guys, it's me, Nigel, here in Braden's basement. I was invited here to talk a little bit about atoms. If you don't know me, I'm a chemist, and I run a small YouTube channel called NileRed. Anyway, let's see what Braden has in his kitchen. PU 239. I think that means 239 grams of pudding. I hope it's plum pudding. Wow, this is some weird pudding. Anyway, I heard you want to learn about protons and neutrons. Let me see if I can grab some for you. Sorry about that. There appears to have been a small explosion, and Braden's basement is under quarantine. Do you know about valence electrons? Atoms like to have 8 electrons in the outer shell, and the closer they are, the more they will want to get to 8 by stealing electrons or forcibly giving them away. This makes them highly reactive the closer they are to 8. Cesium is only 1 away from having 8 valence electrons, so it's super reactive. So naturally I bought some. Inside of it, besides all the sand, is some nice cesium metal. This is very similar to potassium or sodium, but it's even more reactive. It's kept in this glass ampule to protect it from air, and having it break open could be really dangerous. The melting point of cesium is only about 28.5 C, or 83 Fahrenheit. This makes it extremely close, but not quite a liquid at room temperature. If I hold it for another minute or so, I can completely liquefy it. I just have to be really careful though, because dropping it in its liquid form would be an absolute disaster.
And his name is Bababooey. And his name is Bababooey.